Very nice. Welcome to the Banauli Film City. I am visiting Banauli Film City, and I am Fake Newton and Fake Galileo from England. And today I am going to talk about the reference frame. So, see what is reference frame. There are types like inertial and non-inertial reference frame. And also we know about the frame which is fixed on earth and how it is treated. Is it treated like an inertial or non-inertial frame? So first let's define the reference frame. So this definition is given by I, Fake Galileo. We can represent a physical phenomenon or any event by means of certain coordinates. So we see example, the passage of a particle through a certain point in a space at a certain time can be represented by three space coordinates given by x, y, z and a time coordinate t. In order to do so, we must have some material reference body from which the distances x, y, z can be measured, and that material reference body is called origin. Also, we must have some reference process such as the rotation of the earth or the swinging of a pendulum, so that the time t can be specified by stating the stage to which the reference process has advanced. The material means of fixing position and time from a space. The material means of fixing position and times gives a space-time reference frames. A physical quantity has different values when measured by observers in different reference frames. Suppose one frame is attached to the earth, the other is located in a moving train with a uniform velocity, and another one is located on an aeroplane flying in the sky. The velocity of the plane as measured by an observer on the earth will be different from the measured by another observer in the train, while it will be zero if measured by an observer sitting in the plane. If the plane is closed from all sides or train is closed from all sides, the observer in the plane or in the train cannot even tell whether he is stationary or in the motion with respect to the fixed stars or any fixed body at another places. Hence, in order to state a physical quantity or to express a physical phenomena, the reference frame from which it is observed should always be specified. Now, let's know about the inertial and non-inertial reference frames. A reference frame which is at rest or is moving with uniform velocity with respect to the fixed star is called an inertial reference frame. Thus, it is unaccelerated and non-rotating. Any reference frame which is in uniform relative motion with respect to an inertial frame is also an inertial frame. On the other hand, a reference frame which is accelerated or rotating is called a non-inertial reference frame. To clarify this from an example, let's see. Consider a reference frame attached to an aircraft which is making it take off, means accelerated. Run is a non-inertial frame. Similarly, a rotating merry-go-round is also a non-inertial frame. First, the The Newton's first and second laws hold only when observed in inertial reference frame. So here we know that what is a inertial reference frame. A frame which is unaccelerated or non-rotating is a inertial reference frame. This is obvious from everyday experience. For example, according to the first law, a body remains in a state of rest or uniform motion when no external forces is acting on that body. Let us examine this law in reference frame attached to an aircraft, which is a non-inertial reference frame. We know that during the takeoff of run, a passenger feels the back of his seat pushing him forward, although he remains at rest relative to the aircraft. Thus, a forward force does not act on the passenger, but still he remains at rest. Thus, a forward force does act on the passenger, but still he remains in the rest. And this is against the Newton's law. Similarly, if a person wishes to stand at rest on a rotating merry-go-round, he has to push out in a way that a force is exerted on his body towards the axis of rotation. This means that in a non-inertial reference frame, one requires an external force to remain at rest, which again violates the Newton's law. Hence, an inertial reference frame is defined as the frame in which a body at rest and under no external force remains at rest. Now let's consider, see, the Earth has an inertial reference frame. Our laboratory experiments are performed in a reference frame which is fixed to the Earth. In fact, the Earth is not really an inertial frame of reference because it is accelerated due to its daily rotating about its axis as well as due to its orbital motion around the Sun. The centripetal acceleration due to Earth's rotation about its axis for an observer located at the equator is given by A equals to omega square r, where r is the radius of Earth and omega is the angular velocity. Here omega is the angular velocity